So in this video we're going to do the same sort of titration. So again, 100 milliliters of the acid, 0.15 molar. We're adding 0.3 molar sodium hydroxide. The difference here is that the acid is a weak acid. I picked a Ka of 1.8 times 10 to the minus fifth. Probably this is acetic acid, but just to be lazy and sort of more generic, I'm just using HA instead of writing out the formula for acetic acid. Again, I'm looking for the pH. Again, after 0, 1, 10, 48, 50, 52, and 75 milliliters. And I'm being lazy with the sig figs. The problem is exactly the same as the one we did for strong. In order to get through this problem, we're going to set up a table, but there's one major difference in how we're going to do this. If you haven't watched the video on the difference between strong and weak acids in titrations, watch that before you watch this any further. If you have watched it, you remember that the difference between the two of them and the way we deal with them has to do with the fact that the conjugate matters. So when we set up the table here, we're going to set up the same table we start with. We're going to have the milliliters of base that we've added, the total volume, MaVa to calculate moles of acid, MivVib to calculate moles of base, but we're also going to have a column for the conjugate, what's created. So in this case it would be the A- that's created in the titration. Now, again, because this works out so similar to the other one, I've done a lot of the setup already. So I've already put in the volumes of base that have been added. So 0, 1, 10. And I've got another set of the table here, 48, 50, 52, and 75. In each case, I've calculated the total volume, so at 100, then 101, 110, etc. And these values are also the same, 0.015. This is just like the strong titration. So rather than spend the time here, if you're not sure where these numbers came from, go back and watch the strong titration problem. What I want to focus on now is the stoichiometry. Again, this one's pretty straightforward. There's no base added, so that's it. I haven't created any conjugate. All there is the acid. But let's go down a step. Here I've added some base. Strong bases react essentially 100%, so I'm going to use up all of this. It'll become 0. I'm going to use up 0.0003 of this, so 1-to-1 ratio. That's going to leave me with 0.0147 moles of this. Now, where did that go? It became the conjugate. So in the process, I will create 0.0003 moles of the conjugate. Same logic here. I've added some base, strong base, so it's going to react completely. That's going to go to 0. I'm going to use up 0.0030 of this, leaving me 0.0120 moles. Where did those go? They became the conjugate. So 0.0030 moles of the conjugate. Moving down the table, same basic process. At 48 milliliters, again I've added a bunch of base. I'm going to use it all up. I'm going to use up 0.0144 moles of this, leaving me 0.0006 moles of the acid left over. Where did all of this go? It became the conjugate. So I will have created 0.0144 moles of the conjugate. Same thought process here. Again, I'm going to use up all of that. This is the equivalence point, so I'm also using up all of that. Where did it go? It became the conjugate. 0.0150 moles of the conjugate. Get down here. I've passed the equivalence point, so now I have more base than I had acid. So, stoichiometry, this is now the limiting reagent problem. I use up all of that. I use up 0.0150 moles of that, leaving me 0.0006 moles. Now, where did this go? It went over here, so I'm going to get 0.0150 moles. It's tempting to think that this number should go up, but remember this is a limiting reagent. I can't make more conjugate than I started with acid. So for the rest of the problem, this number will not go up. That's as much as I can possibly make. The last step, slide that up a little bit. I have 0.0225, 0.015, the smaller number I'm going to use up completely. I'm going to use up 0.0150, leaving me 0.0075 moles of the base. Where did all of this go? It became the conjugate, 0.0150 moles of the conjugate. The table is now fully set up. We've done the stoichiometry. Now we have to do the real work.